Greetings, salutations, all those nice things. Today we are going to finish off topic 7, which is trigonometric functions and cyclical graphs, by looking at the tangent function. I will admit the tangent function isn't really my favorite of the trigonometric functions, but it is a trigonometric function nonetheless, and it is a cyclical graph. It is not a sinusoidal function. The sinusoidal functions are y equals sine x and y equals cosine of x. And this is a ratio between these two. The cool thing about tan is that it's the quotient between sine and cosine. So we can use this information to help us find values of tan x to place for a table of values to make this whole graph. If you happen to know these values already, you can just go with that. But for now, in case you don't, we'll use values of sine x and cosine of x and find the quotient between those to get tan of x. So we know that sine of 0 is 0. And if you use a unit circle or you use a special triangle or something, pi over 4, however you get these values, you know that sine of pi over 4 is 1 over root 2. Sine of pi over 2 is 1. And then sine of 3 pi over 4 is 1 over root 2. And we see a pattern kind of emerge where it goes up to its peak, and then it goes down, and then it goes beneath that to the bottom, and then it starts coming back up. And that's its full cycle. And cosine of x, cosine of 0 is 1. Cosine of pi over 4, however you get that, is 1 over root 2. Or you can say root 2 over 2 as well. Doesn't really matter. One just has a rational denominator, same value. Anyhow, we continue here. And these are values you should be able to get. If you have questions on how to get these values, then let me know. That is certainly expected at this point in time. Boom, done. So again, we're going to look at this business here, that tan of x is equal to sine x over cos x. And we'll use that to get our values of tan over here. So here, sine x over cos x is 0 over 1, which is 0. That's one way that we know that tan of x, or tan of 0, is 0. Here we have 1 over root 2 divided by 1 over root 2. So it's only divided by itself, and that gives us a 1. And we can also get this from the special triangle here, right? Just taking a look at, there's pi over 4, and opposite over adjacent is equal to 1 over 1, hence 1. So we get that value there. And now we have tan of pi over 2. And for that, we're looking at 1 divided by 0. Whoa! That's not a real value. In fact, 1 over 0 is undefined. It's so sad. Well, then we go over here. We have 1 over root 2 divided by negative 1 over root 2. So something divided by the negative of itself. So negative 1. 0 divided by negative 1 is 0 again. Something divided by itself is 1. Negative 1 divided by 0. Whoa! That was scary. But no, we cannot divide by 0. So this is also undefined. And then the negative of something divided by that thing is a negative 1, and 0 divided by 1 is 0. So this is how a pattern emerges for the graph of y equals tan x. We can plot the point 0, 0. We can plot the point pi over 4, 1. And we can plot these other points, 3 pi over 4 and 1, pi 0. And then a pattern comes to be. We actually see that there are, two cycles in here. From 0 to 360, this pattern happens twice. 0, 1, undefined, -1, and does it all over again. How do we plot this undefined part? Well, that's just going to be a vertical asymptote. Now the function is just going to trend toward it as we approach that x value. So looking at this, every time there was an undefined in our graph, so where we had pi over 2 and 3 pi over 2, we had a vertical asymptote. We plotted the other points, so 0, 0 was right here, and then pi over 4, 1 is right over here, and then again, we reached that vertical asymptote. It was so sad, but the function just trended towards it, so it just said, oh, I'll just keep going up here. On the other end, we knew it was coming up from 0, it hit that -1 at 3 pi over 4. So how did it behave near the asymptote? Well, it just kind of trended towards it. It didn't trend towards it this way, not in the positive direction, because tan is negative for this entire region. We know that from cast rule, we can know that from unit circle business, there's a number of ways to know that. But it does have to go that way, so it has this little split C here. If we look at the period of the tan function, so I did note a moment ago that we've actually got two of these in that 0 to 360, or that 0 to 2 pi, which means, I said three of those? No, we have two. We have two of these. We have 1, 2. 2 cycles from in that range. So if 2 of them happen in 2 pi, 1 of them happens in a single pi. And we see that with the distance between the asymptotes here. That distance, that period, is equal to pi. So when you have a b value that's playing around with things, that's causing stretches, compressions, that's what it'll affect, is that period. And then a c value in the function transformation, something to shift it left and right, will affect where this asymptote actually starts. When we are transforming the tan function, there are some keys to look at. One is the x-intercepts, so where does tan of x actually equal 0? We're going to look at the points where tan of x is equal to 1, because those are nice key values that we can transform in terms of our vertical transformations. And then the vertical asymptotes, which are affected only by horizontal transformations. So if we shift up, down, or we multiply vertically, we're not going to see any change in the asymptotes, but only those b and c values. And that's about that. We're going to try graphing one. Woo! It could potentially be a doozy, but we'll see what happens. Just going to pull out this trusty color here that I like to use for axes. Using my ruler, I draw a nice straight line. And yeah. This will be y. That'll be x. Let's figure some things out. Originally, my period was equal to pi. In this one, I am multiplying all the x values by 2, which means I'm employing a horizontal stretch by a factor of 2. So this period is going to be 2 pi. And that means that we're going to see the vertical asymptotes all spaced 2 pi apart. So one of the original asymptotes happened when x was equal to pi over 2, but now that's getting transformed. We are multiplying it by 2, and then we are also subtracting pi over 2. So we're employing those transformations to any of our horizontal aspects. So one of our new asymptotes, we're going to take our original one, x will be equal to our original one, but we're going to multiply it by 2, again because of this transformation, and we're going to subtract pi over 2 because of this transformation. So we do have a new asymptote at x equals, pi over 2 times 2 is pi, minus half is still that. So that's kind of nice. Other transformations, we look at what happens when y was equal to 0, when y was equal to 1, and when y was equal to negative 1, what happens to those? And for our vertical transformations, there's no plus anything here. We are just multiplying by 4. So y equals 0 times 4 is still 0. Y equals 1 times 4 is 4. And y equals negative 1 times 4 is negative 4. We now have all the info we need to graph this thing. Boop. Excuse me. We are going to absolutely have to make sure that we have a tick mark for pi over 2 for our x scale. Our next asymptote will be 2 pi over from that, and that is a multiple of pi over 2. So as long as we have multiples of pi over 2, we're good. So maybe I'll put a pi over 2 here, and another one here, and that'll be another one there. So all of these will each represent a single pi over 2. Note we are taking care to make sure that these are evenly spaced-ish. They don't have to be perfect, but they should look pretty close. So I don't have like one here and then one there, and another one there, and that. And that is messy, that is sloppy, and you will not get full marks for it. So evenly spaced as much as possible. We don't have to label every single one. We do have to at least label one of them to represent what one tick mark represents. For our vertical scale, we need to make sure we can indicate where 4 is, where negative 4 is, and where 0 is. Well, 0 is already taken care of on the origin there. And for 4, negative 4, we can just do that. That bottom one's a little, that looks better. So that can represent 4 from there. If I want, I can write the negative 4. That's fine. And from here, we are essentially plotting points. I like to start with the asymptotes and go from there. I know I have an asymptote at x equals pi over 2. So I'm going to draw that in. So this is x equals pi over 2. Where's my next asymptote? Well, they are all spaced 2 pi apart. So that would be, this is 1, 2, 3, 4 pi over 2s. So this is where my next asymptote will actually be. Not these other ones. And not on pi over, not on 2 pi, right? This is my mark for 2 pi. Not on there. I'm saying that the distance from one asymptote to the next has to be 2 pi. So that's why this one is, I should start that from a different point. What is that? That's pi over 2, no, it's 2 pi plus pi over 2. So what's that? This isn't the straightest asymptote I have ever made, so I'm just going to fix it a little bit. It is pretty necessary. Oh gosh. Let's just try that one again, sorry. asymptote should be pretty straight. Yeah. And then I could draw another asymptote in the other direction. 1, 2, 3, 4. Have one come out there. What is this? It's 3 pi over 2. Neat. So I've got my asymptotes. Asymptotes are taken care of. Let's see what happens between the asymptotes here. Halfway between the asymptotes is this, where that 0 occurred. And then halfway between that and one of the asymptotes will be our 1. Halfway between that 0 and one of the other, on the left asymptote, will be this -1. And that's what we can use for plotting the rest of this here. Halfway between these two asymptotes, is this x value here. And what will that transform into? It was y equals 0, now it's, still y equals 0. So I can put a dot right there. Now this should be following like this kind of pattern. That's how the tan function looks, ish. Where does that next point occur? Well, that's halfway between that mid value and that asymptote. So in this case, it happens when x is equal to 0, but not this y value. The y value will be 4. So I've got that point here. And on the other side, the -4. And that pattern is going to repeat. I'm going to have a 0 right there. I'm going to have a -4 on its left side and a +4 on its right side. From here I can really just connect the dots. Do be careful that it's not just like, that's not quite how this goes. It does curve a bit, so try and make it do so. And I start like this, where this is angled such that if this line was drawn straight, it'd be a little too high there, a little too low there. And then that way I can actually get a bit of a curvature to it, because I have to force it in this way to make it actually curve through. So this can keep going down this way. On the other side, you can't see me doing this, but I'm turning this thing upside down so I can actually draw my sketchy lines nicely. I have trouble drawing them when they're upstrokes. You're allowed to move your paper around. So that's that first cycle. And let's draw another one, because we can. There's that. And trends towards the asymptote on the left. And it trends, wait, I'm going to turn this upside down again. And it trends toward the asymptote on the right. We could put more periods of this function if we want. This is sufficient, that's all we really need to do. So this one is considered done. So that's about it. Again, I start with my asymptotes once I know where the asymptotes are. And then I can say halfway between that is my transformation of y equals 0. And then I can figure out where my transformations of y equals 1 and -1 go from there. That's really all there is to it. There is some practice work in the textbook for you to play with over there. I would recommend giving it a go, giving it a shot, giving it a whirl, giving it a stab, giving it an attempt. But then also there are some questions from the 2019 January Provincial for you to look at. So not a whole ton for trig functions on that graph, but this one is certainly worth a good number of marks. So we have now closed this topic. We will have to assess on it at some point. If you have questions as you work on any of these things, or even on the other path provincial questions, don't forget to use that database. Please do let me know. The more questions you ask, the more questions I can answer. So that's about that. Thank you, everyone, for your enthused participation in topic 7. And I will see you when we do more trig in topic 8. Goodbye! Click.